Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself, Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. So in this lecture, we are going to discuss about the principle of nanofiltration membrane, transport mechanism in nanofiltration, transport mechanism of charged solute, and basic fundamental concept of nanofiltration. So let's continue with the principle of nanofiltration. Nanofiltration employs a pressure gradient to selective transport solvent and certain solute across the membrane. Nanofiltration spans the gap in particle size between reverse osmosis and ultrafiltration. It is also called as ultraosmosis, and a nanofiltration membrane may be considered as a very tight UF or very loose RO membrane separation process. Nanofiltration in concept and operation is a much same as a reverse osmosis, but membrane use are slightly more permeable, so less pressure, and can say that which translate into the less energy requirement for the separation. Another difference is degree of removal of monovalent ion such as chloride. Reverse osmosis remove monovalent ion at 98 to 99% level at 200 psi. On other hand, removal of monovalent ion by nanofiltration membrane varies from 50% to 90% depending on material and manufacture of membrane. For this reason, there is a variety of nanofiltration membrane available, which type is particularly studied to certain application and may not be acceptable to different application. So nanofiltration apply a pressure gradient to selective transport solvent and certain solute across the membrane. Nanofiltration span the gap in particle size between the reverse osmosis and ultrafiltration. So it's also known as a ultra osmosis and very tight RO, or can say that very tight reverse osmosis. The size of solute excluded in process is order of 1 nanometer. The filtration process takes place on selective separation layer formed by organic semi-permeable membrane. The driving force of separation process is a difference between the feed and filter, or can say that retentant and permeate. The driving force of separation process is a pressure difference between feed and filtrate, or can say that retentant and permeate side at a separation layer of membrane. However, because of selective one or various component of dissolved mixture are retained by the membrane, while water and substance with molecular weight cutoff of 3200 Dalton are able to permeate the semi-permeable separation layer. So these all are basic fundamental concept of nanofiltration. Now let's discuss about the nanofiltration membrane. The pore size of nanofiltration membrane correspond to the molecular weight cutoff value of approximately 300 to 500 gram per mole. Therefore, separation of component with this molecular weight from higher molecular weight component can be rejected. Moreover, nanofiltration membrane have a slight charged surface because the dimension of pores are less than one order of magnitude larger than size of ions. Charge interaction play a dominant role at that surface of membrane. The effect can be used to separate ion with different valence. Nanofiltration membrane are generally consist of two separate parts. One, a thin barrier layer which act as a separating layer, and second is a microporous sublayer which made of the fiber which act as a supporting barrier layer of the thin that layer which useful for the separation. So nanofiltration membrane consists of two layers, one which is a thin barrier layer which act as a separating layer, and second layer is a microporous sublayer which act as a supporting layer of the barrier layer. So polysulfone provides an excellent support for very thin high selective desalination membrane. In flat sheet membrane, fibrous web provide the mechanical strength and therefore the support layer can be made. However, fiber must be support and they are required to withstand a compression pressure in range of 300 to 400 psi. Consequently, fiber have an alternative thick wall resulting low permeability. A hollow fiber reinforced with fiberglass has a high compression and collapse pressure. To meet this objective, base fibers are developed from three different polymers. These are polysulfone, sulfonated polysulfone, and polyamide. The fibers are reinforced using hollow fiberglass braid as a support. In addition to strengthening the fiber, this allows the use of dope with lower viscosity. High viscosity dope yield fiber with lower flux and higher comprehensive strength. So, nanofiltration membrane is made of two layers. Layer 1, which is the act as a separating layer, or can say that thin barrier layer. So in here we can see this is a nanofiltration membrane where two layer, first layer which is a thin barrier layer which used for the separation, and second layer which is used to support this thin layer. This supportive layer is made of fiber where mostly this upper layer, or can say that thin barrier layer, made of polyamide. Nanofiltration membrane is a slight charge in nature, so we can separate ions from this nanofiltration. So this layer is mostly made of the charged solute such as a polyamide, and mostly nanofiltration membrane are manufactured using the interfacial polymerization. In interfacial polymerization, there is a one phase which is a organic phase and second phase which is a aqueous phase. Between these two phase, reaction occurs and we will get a thin barrier layer which used for the separation purpose. So, nanofiltration membrane can separate using the steric effect and electric effect, which known as a Donon effect in membrane separation process. So, in nanofiltration, we can separate the solute on basis of the molecular size, and also we can separate using the charge of that solute. So this is all about the nanofiltration membrane. Now let's discuss about the transport mechanism in nanofiltration membrane. The mechanism of transport and rejection characteristic of nanofiltration membrane are quite complex. Many models have been developed to identify the effect of different parameters on transport mechanism and predict the nanofiltration performance. The two major theories are developed for transport mechanism in nanofiltration membrane. First, which is a Sauri-Rajan Thompson surface capillary flow approach, and second one, which is a solution diffusion theory. Thompson surface capillary flow theory describes the preferential sorption of water molecule in a membrane and the desorption of multivalent ions, exclusion of charged solute even smaller than the membrane pores from monovalent into the membrane. Effective charge density, pore radius, and ion strength determine the rejection of monovalent ion. But generally speaking, nanofiltration membrane, the rejection of monovalent ions range between 0 to 50%. Thompson diffusion theory describes the membrane as a porous film into the which both water and solute dissolve, or can say that ion also dissolve in the membrane. The solute move in a membrane mainly under concentration gradient force, while the water transport is depend on hydraulic pressure gradient. The transport of solute through the membrane depend on diffusion and convection. The transportation of uncharged solute through a nanofiltration membrane is considered to be determined by the steric exclusion mechanism. Steric exclusion apply to the nanofiltration membrane as well as ultrafiltration membrane and microfiltration membrane. A separation between two different uncharged solute is determined predominantly by the difference in size and shape of the solute and pore size and shape of the membrane. So this is all about transport mechanism in nanofiltration membrane. So now let's discuss about transport mechanism of charged solute. For charged solute, there are two additional distribution mechanisms such as Donan exclusion and steric effect. In Donan exclusion, compared to the pressure-driven membrane separation process, has effect on separation in nanofiltration due to the slight charge nature of membrane. Solute with opposite charge compared to the membrane are attracted while the solute with similar charge are rejected. At the membrane surface, distribution of co and counter ion take place, thereby causing an additional separation. Where, according to dielectric exclusion theory, water molecules show polarization in pore due to the charge of membrane and dipole moment of water. As result in water molecule will show polarization in pores. The polarization result in decrease of dielectric constant inside the pores, thereby making it less favorable for the charged solute enter into the membrane. However, even in situation that the dielectric constant inside the pores is required or is equal to the one of the water, a change in electrostatic free energy of the ions occurs when the ion is transferred from bulk into the pores. This is also result in exclusion. Dielectric exclusion play major role in electrodialysis. The relative importance of these two mechanisms in nanofiltration is a still point of debate in scientific community. Most of this literature on nanofiltration use Donan exclusion as a distribution of mechanism. So mostly we are going to use Donan exclusion effect for the nanofiltration membrane. So using Donan effect can say that the surface of nanofiltration membrane, if surface of nanofiltration membrane is positive charge, then it can pass negative charge solute and reject positive charge ion. So nanofiltration membrane work on Donan exclusion as well as the dielectric exclusion theory and the size exclusion theory. Mainly Donan exclusion theory and size exclusion theory mostly used for the calculation of rejection for the nanofiltration membrane. So let's consider this is a one nanofiltration membrane. Now, what is a size exclusion theory? In size, let's consider there is a pores. This is the pores of nanofiltration membrane. If solute bigger than this pore size that cannot pass from this pore, so it will be rejected from the membrane. So this about the size exclusion theory. Now let's talk about Donan exclusion theory. In Donan exclusion theory, the upper layer of the membrane is a slight charge. Let's consider this layer is a positive charge. So, solute that smaller than this pore size and it's a positive charge, then it cannot pass from the pores due to the Donan effect. It will be reject from the membrane. But if solute smaller than particle of the pore size, and let's consider this is a negative solute or negative ion which can pass from this membrane. So nanofiltration membrane work on this both theory, Donan exclusion and size exclusion. So this is all about today's lecture. In this lecture, discuss about the various principles of nanofiltration, then discuss about the nanofiltration membrane, then discuss about the transport mechanism of nanofiltration membrane and transport mechanism of charged solute. So this is all about today's lecture. Thank you.